Okay, so what I need to do is talk about a different type of problem. Sometimes I got to split these videos up because of the time, but I'm still on the same concept as last time, looking for the looking for all the zeros. And notice the zero this time that they gave me. And so there will come a time when I won't give you any zeros, but so far we're talking about how to solve these problems, and you're given a zero. The zero that they gave me is an imaginary number. And there's a rule that says that anytime you have an imaginary number as a solution or something like that, its conjugate, they call these complex numbers, by the way, in the actual mathematical way of saying it, its complex conjugate is also a zero as well. So if you know one of them, then you should automatically know that the other one, or the conjugate, or the opposite, basically, when you change its sign, both of these are zeros. Now, I was only given this one, but I know that whenever I'm given an imaginary number solution, then its opposite or complex conjugate also is the same thing. And conjugate basically means change the sign of that number in front. The coefficient there, change the sign. And so I know automatically right off the bat that both of these are zeros. Why is that important? Because this one is a little bit different. Since I haven't been given a real or what they call a rational number, I can't do synthetic division. I don't put 5i in the box here and start trying to do 1 and 16. No, you don't do that. That's incorrect. And so what you have to do is start here. If you're given 1, then you know that the conjugate or the opposite sign of that one is also a solution. But this is only if you're given imaginary numbers, if you see that I in there. Now, what do you do with those? This is important because we're not going to do this same thing. The idea is to take x plus 5i, which is what that would be as a polynomial, and x minus 5i, and we're going to FOIL those out. And when we FOIL these, you'll get x times x is x squared, and negative 5xi plus 5xi minus 25i squared. Alright? That's when you FOIL all of that. Now notice what happens to these two middle terms here. They cancel out. And remember, I squared equals negative 1. So negative 25 times a negative 1, this really is x squared plus 25. This right here actually simplifies down to x squared plus 25 whenever you FOIL it out. Alright? So that's the first step, is to take the two that they give you and go ahead and multiply them out in a manner like this. Okay? Now, why do you want to do that? Well, I know that this is a factor of that. A factor goes into that. Say, what? X squared plus 25 is a factor of this now. What that means is something times x squared plus 25 equals that. So we can use division to figure out that something. So let me actually tell you what we're going to do. We're going to take x squared plus 25, and we're going to divide it into x to the fourth plus 0x cubed plus 16x squared minus or plus 0x minus 225. Say, what, Mr. Freeman? Well, we found this, and now we're going to divide that into this. Why? Because I need to figure out how to factor or all the zeros, the rest of the zeros. If I know that these two are zeros, I was given this one, but I automatically then know that this one is a zero. I multiplied and found out that this polynomial right here is a factor of the original equation. So I take that and I divide it into the original equation. But remember, if you're missing cubes or to the first power, you need to put the 0 in its place. This is all old stuff. This right here is probably new. But this part right here should not be new. So long division says x squared times what equals x to the fourth, and it's x squared. X squared times x squared is x to the fourth. X squared times 25 is 25x squared. If you change the signs here and you bring everything down, it's possible that you may not need this 0x cubed. But I'll bring it down anyway. That's minus 9x squared plus 0x minus 225. Okay? Since I don't need to have an x cubed factor there, it's okay. I don't have to do 0x squared up there. It's kind of like adding 0 to both sides of an equation. It's not necessary. Alright? So what I'm going to do is skip right over, because it's not necessary. Hopefully y'all understood what I just said. If not, talk to me in class. Negative 9x squared. What do I multiply x squared by to get a negative 9x squared? Well, it's a negative 9. Negative 9 times x squared is negative 9x squared. Negative 9 times 25. I don't know, but I have a handy dandy calculator right here. And so it's 9 times 225. And that is, because I don't know how to multiply. Alrighty, I'll get it right. But of course, you got to change your signs when you get down here. And so when you do this, look what happens. Everything drops out to be 0. I said that x squared plus 25 was a factor. If you don't get a remainder of 0, then you did something wrong over here. If it's a factor, you should get a 0 as a remainder. But look at what I have here. Isn't this easy to figure out now? Notice that my exponent is a 2. I know several things, or I can just take x squared minus 9 and set it equal to 0. I could factor that, x plus 3, x minus 3, and that's x equals negative 3 and 3. Or if I wanted to, I can take the same problem, x squared minus 9 equals 0, add 9 to both sides. That's x squared equals 9, take the square root, and x equals plus or minus 3. I get the same thing either way. See, our goal is to try to make what we have go down to the second power, because we got all kinds of tricks that we could use to solve and factor something that's x to the second power. So let me review real quick what just happened. I was given this problem right here, and I was told that 5i was a 0 here. But 5i is an imaginary number. It doesn't really exist. There's a rule, I forget the name of the rule, but we can look it up and talk about it in class, that says if you are given a 0 that's an imaginary number, or a complex number is what they call them, then its complex conjugate is also a 0. In plain English, that means that the opposite of it is also a 0. So if I was given 1 plus the square root of I square root of 3 or something like that, then I also know 1 minus I square root of 3. Not negative 1. You don't change that. It's just that sign in the middle changes. Okay, that's a rule. And we can talk more about that as we get more involved, but we should be able to understand that from this standpoint. So once I get those two, or know those two exist, then I went ahead and multiplied those two, x plus 5i, x minus 5i, and I multiplied them, and I got x squared plus 25. When I did my FOIL, remembering that I squared equals negative 1, so negative 25 times negative 1 gave me a positive 25. Why is that necessary? Now, I know that this is a factor. It definitely divides into that evenly. So I know how to do long division. Remember, we talked about long division. And so I went through my long division process, and I got a remainder of 0, which I should have if x squared plus 25 really is a factor. Now, since it gave me x squared minus 9 as my quotient, what I did was I took that and I set it equal to 0, and I factored to get my other two solutions, and or I solved for x squared or x by using square roots. These are things that we talked about in previous weeks. So all this stuff, things that we've done before, is all coming back. And if you took a little bit of time to try to hurry up and get enough understanding so you can pass a test or a quiz or copy off somebody, now it's going to come out to bite you, because now you got to relearn this all over again. If you actually knew this and you actually could do it at a time, once we get back on it, it'll come back. I promise you. Now, as you can tell, our math is getting a little bit more complex. Not hard, but just complex, meaning you got one more step and another step. And I got to reach back from a couple of weeks ago or last semester to have something to fall back on. Now, hopefully you understand why I said I would at least keep my notes in there, because there's notes in here to describe if you forgot how to do this. Okay, why are we doing this again as the whole picture? What we're trying to find is the roots or the solutions, and that's really where our function crosses the x-axis. It's nice and neat whenever it's x squared, but x squared is not the only kind of polynomial functions out there. X cubed, x fourths to the fifth, to the sixth, it keeps going and going and going. And so the plan of action is we can do synthetic division if they give us a real root. We have to do this process if they give us an imaginary root. What's that process? We automatically know that the conjugate, or change the sign of the number there, or not really a number, of the imaginary number there, or the complex number, and take those two and FOIL them out. And what you will get as your product there is going to be a factor of your original function. Then you got to pull out long division. And then your quotient there is something that you ought to be able to work with or do some more synthetic division to. All right. Hopefully that helps. Don't let this stuff catch up on you or creep up on you like waiting to the last minute.